Welcome back to All This Math. This is Professor Parker, and make sure you are subscribed to the All This Math YouTube channel. Make sure you drop a comment down below. Make sure you like this video. Make sure you share this video with somebody, especially if they're trying to learn how to develop their skills with percentages. Percentages are a very important concept. I actually think like percentages are like a language, right? We should be able to understand percentages when we see them. We should be able to understand percentages when we hear somebody talk about them and throw them around. Because I know people don't be understanding what people be saying when they be like, this went up 42%. And last year's projections were like 22% lower than the goals and the target. People don't be understanding. You should, though. I got videos on this channel that can teach you how to understand percentages. What does that really mean when people be talking about percentages, and how do you calculate them yourself? And how can you verify that the percentage is correct? Which brings us to this video today. So we're going to do some music math, right? Because as we all know, we hear all types of outlandish things on the internet. Some things are true, some things are not true. So I'm just in the habit of like verifying things using mathematics, right? So somebody was talking about somebody that like really doesn't like Drake was talking about his album streams from the first day this new album he put out came out on February 14th. This person said that there were 28,830,492 streams. And then a day later, on February 15th, 2025, just one day later, there were only 16,110,553 streams. So this person said that that represented a 44% drop in streams from the album release date to the next day. So me being me, I'm like 44%. Let's verify that. Let's see if that's right. It's a way to practice some math, you know what I'm saying? And see if the person is telling the truth. Now, I can't verify these numbers, or I didn't verify these numbers, but I can verify that if these numbers are correct, that whether that is a 44% drop or it's not a 44% drop, right? We can do some basic math dealing with percentages. So what we're talking about is basically a percent change, right? And there's a formula for that. It's called the percent change formula. So basically what we're saying is we want to know, because percent is just a fraction. A percentage is another way of representing a fraction where your denominator would be 100. So it's a way to like standardize information, right? So instead of comparing fractions with different denominators and different numerators, we can just have everything have a denominator of 100, and we call it a percent. So we all on the same level, on the same playing field. That's why it's called a percent. Cent means 100, right? So out of 100, right? So out of every 100, all right? So out of this much we started with, we see that this number is less than that number. So that means it should be a percentage decrease, meaning it went down. But what is the percentage though? You know what I'm saying? So of course, if it went back down by 100%, this would be zero, right? Because all of this will be gone. But you see only some of this went down. It went down by some. So we want to know what percentage that is. So let's write the formula on the board. So the formula for percent change is like this. So this is percent change. And I'm going to use the triangle, which stands for, it's the Greek letter delta, which means change, right? Just like in slope. Slope is like rise over run, the change in y divided by the change in x. That's the change, you know what I'm saying? In physics, you're going to see this, the change, right? So instead of writing out the word change, we can just use symbols, all right? Delta. They like emojis. That's all it is. Ain't nothing too crazy, all right? So percent change is equal to, what is it? New minus old divided by old times 100. Now, what does that mean? What does new mean? New means out of the two numbers you're comparing, the new number is the more, we think in terms of time, the more recent value, right? That's the new value. So October 14th, this is the number of streams. October 15th, this is the number of streams, which is new. The newer date, the more recent date is February. I said October, I meant to say February. The more recent date is February 15th. So this is our new number right here. What's our old number? The day before, 28,834,92. And this is also how we know it's going to be a percent decrease, because when our value ends up being negative using this formula, that's how you know it's a decrease. If it ends up being positive, that's how you know it's an increase, right? Because look, what happens when you subtract a bigger number from a smaller number? And yes, you can do that, even though some elementary school teachers, like one I had many, many years ago, I don't even remember who it was. It was somebody though. They told me you can't subtract bigger numbers from smaller numbers. It's untrue. You can do that. I think, they just wasn't ready to teach me about negative numbers, right? But you can subtract bigger numbers from smaller numbers. You just get a negative value. All right. Just like when you overdraw your bank account, you overdrawn. You got a negative value in your account. So, all right. So the new value is 16 million, whatever. The old value is 28 million, whatever. And then you do new minus old, right, to find the difference between these two. And then what you want to do is you want to find what fraction is that difference out of the old amount that you started out with. Again, what fraction is that difference, the difference between these two, right? What fraction is that out of the amount that you started out with? Like I said, fractions, percentages, decimals, they're all like cousins. They like cousins or like siblings almost, right? They're different ways of expressing the same information, right? It's like talking in different languages, but you saying the same exact thing, right? It's like using slang and vernacular from different parts of the country or whatever, right? So you got new minus old. That's going to give you the difference between these two streaming amounts, right? And then you're going to take that number and divide it by the old amount. It's a fraction of that. And then you take the fraction and then you divide it. That fraction is going to turn into a decimal. And then that decimal is going to turn into a percentage by multiplying by 100. All right. So for this, I'm going to take out my calculator because this is a good calculator problem. All right. So what we're going to do is we're going to do this. The new is, let me just do this. I'm going to just write it out. The new value is my February 15th for my more recent value. My new value is my more recent value, my more recent numerical value, right? So I got 16,110,553. And then I'm doing my subtraction sign. Minus what? My old value. My older value, right? Not my most recent. 28,834,92. So I got 28,830,492. And then I draw my fraction bar like this. And then my old value, I write it again. See, I write it twice. Because again, this is a fraction out of the original amount. So then I got 28,830,492. My last step is to multiply by 100. So I'm going to subtract this minus this. Typed in on my calculator. Make sure you know how to use your calculators. Make sure you own a calculator. Don't rely on the calculator on your iPhone or your Android or whatever. Don't do that because it's too many distractions. You'll be trying to, calculate something that somebody texts you. You get a notification on Instagram or whatever. You know what I'm saying? Like you don't got time for all that. You need to get you a good like $10 scientific calculator, right? So you can stay focused. All right. 16,110,553 minus. I use my phone calculator sometimes, but can't use it now because I'm recording this video with it. So you know what I'm saying? But anyway, 16,110,553 minus 28,830,492. That's going to be negative. What's that? 12,719,939. How do I know where to put the commas at? Starting from the right, every 3 digits you put a comma. Every 3 digits you put a comma. 939, comma. 719,000, comma. 12 million, negative 12 million. So a drop of 12 million streams, almost 13 million. Notice how I said almost 13 million. I rounded. That's rounding. You got to know how to do rounding too. I got videos on the channel about rounding. You got to know how to round. That's almost 13 million because it's 719,000. So 700,000 is close to 13 million. So it's going to make the 12 million go up to 13 million. Really down technically because we're on the negative side of the number line, but that's another conversation for another time. So then we put our denominator 28,830,492 times 100. Sorry for the squeaking if that bothers you. You know what I'm saying? So look, divide this by this. We're going to divide it by 28,830,492. And we get negative 0.441197,431. Multiply that by 100. That's going to become negative 44.1%. So the person on the internet was correct. That is true. Based on these numbers, that is a 44% drop. Now it's negative, which means it's a drop or a decrease. The 0.1%, that ain't nothing too crazy. We could, if I rounded this to a whole number, well, it wouldn't be a whole number, but if I rounded it to an integer, well, if I treated it like a positive and I just said, all right, 44% drop, you know what I'm saying? Now it is a whole number. So yeah, 44% drop. So that's true. And look, this is the whole purpose of this is just to get an opportunity to use the percent change formula. This is something you should know. Percent change. New minus old divided by old times 100. New minus old divided by old times 100. That's all it is. Ain't nothing too crazy. All right. So, yeah. And we see these examples. We see numbers all the time. We see data all the time. And if you're a parent watching this, there's numbers all around you. There's plenty of opportunities for you to practice math with your children. Don't wait for the school to teach your children everything, right? The school's not, most likely, the school is not equipped to do that anyway. School should be a space for practice. Remember where you heard that. School should be a space for practice. You might have never heard that before. You're going to hear it more often, though. Watch. School should be a space for practice. All right. So that means that the house, the neighborhood, the block, the community needs to become the primary educational space, right? That's something you can control. All right. Can't control what goes on in the schools unless you control the schools. But that's usually not the situation. So, like I said, get some practice with the percent change formula. Make sure you subscribe to the channel. Drop a comment down below. Share this video with somebody. All right. See y'all on the next video.